Welcome back, students, to the course of Computer Graphics and Multimedia, CAPOL 208. So, I am SENTHIL SELVAN. So, this is unit number 2. So, already in unit 2, we saw about the input devices, the output devices, software, graphic software, functions, standards. After software standards, line drawing algorithm, we saw DDA algorithm. So this session, we are going to see about Bresenham's line drawing algorithm. This is another type of line drawing algorithm. So in the previous DDA line drawing algorithm, we have some drawbacks so during the round off, actually, so we are getting a jagged output. We are not getting a smooth line. It's unable to construct a smooth fitting line using the DDA algorithm. That problem is because of the round off values to the nearest pixel. So, but Bresenham's algorithm is algorithm is different. So, how it's calculating the intermediate points, we'll see one by one. So, in Bresenham's line algorithm. So this is an accurate and efficient raster line generating algorithm developed by Bresenham. That's why the name itself they are given as Bresenham's line algorithm that uses only the incremental integer calculations. So in addition, Bresenham's line algorithms can be adapted to display circles and other curves. So the vertical axis shows the scan line position and the horizontal axis identify the pixel columns. So sampling at unit X interval in these examples, we need to decide which of two possible pixel positions is closer to the line path at each sample step. Starting from the left point, so from left to right, we are going to plot it. So we'll decide either we have to stay back in YK or we have to proceed to the next pixel. So we have to decide it based on the PK value. So that is the decision parameter. Based on that decision parameter only we'll decide either we'll move to next location or next pixel, or we'll stay back in the previous pixel itself, YK. So this is XK, YK. Next XK plus 1 will increase. But what about Y? We have to stay back in YK or we have to move to YK plus 1. So that thing we are going to decide it. So using this Bresenham's line algorithm. So consider the scan conversion process for lines. So with the positive slope, less than 1. So assume that we have determined that the pixel at xk, we are currently in xk, yk. So choices are the pixel at position xk plus 1, yk and xk plus 1 or yk plus 1. So we have to decide either we have to stay back in yk or we have to move to yk plus 1. So this we will decide based on the decision parameters of pk value. So here y coordinate on the mathematical line at pixel columns, so position xk plus 1 is calculated as y equal to the slope xk plus 1 plus the y-intercept b. So in the Bayesian algorithm, sampling position at xk plus 1, so we label the vertical pixel separation from the mathematical line path as d lower and d upper. So this one. So the d lower is y minus yk, that distance. So lower is y minus yk, so that is equivalent to slope of xk plus 1 plus b minus yk. And d upper equal to yk plus 1 minus y, so which is yk plus 1 minus, instead of y will substitute m of xk plus 1 minus b. So from this we can determine which of the two pixel is closest to the line path. Set up an efficient test that is based on the difference between the two pixel separation as follows. D lower minus D upper, the difference we'll check, so which is closer, so that pixel position we'll choose it. So either yk or yk plus 1. So D lower minus D upper equal to 2 times of slope xk plus 1 minus 2yk plus 2b minus 1. So the decision parameter pk, so every time, so in each iteration, we'll see the decision parameter. So based on this thing only, so we'll decide if slope is less than 0, x value will keep on incrementing. So y we have to decide. So either we have to stay back in yk or so yk plus 1. The decision parameter pk for the kth step in the line algorithm so can be obtained by rearranging the equation. So pk equal to, so del x d lower minus d upper. That d lower minus d upper, just substitute this 2 times of slope xk plus 1 minus 2yk, and this thing is substituted under. So this to be minus 1, so it's so constant c equal to 2 del y plus del x to be minus 1. So constant c. So rest of the things 2 del y into xk minus 2 del x into yk plus c. Sign of pk is same as the sign of lower minus the upper. The value of c is given here, so every time we'll calculate this. At step k plus 1, the decision parameter is evaluated like this. So pk plus 1 equal to 2 del y into the next portion xk plus 1 minus so 2 del x into so yk plus 1 plus c. So c the constant value, so already I told it to find the pk plus 1 in terms of pk, subtract pk from pk plus 1. So in the next every iterations we have to calculate this pk plus 1 minus pk equal to 2 del y, so xk plus 1 minus xk current position, previous position, minus 2 del x yk plus 1 minus yk. So based on the decision, either we will stay back in current position means yk minus yk, so this will become eliminated. So otherwise it will change. Del 2 del x will come in the calculations. Substitute xk plus 1 in this portion xk, so we will get pk plus 1 equal to pk plus 2 del y minus 2 del x. This term, so xk will be eliminated. So 1 will come, so 2 del y, anything with 1, same thing will get 2 del y. Minus rest of the terms will get. So this is the equation, so important, the decision parameter pk plus 1. So each time we are calculating the intermediate point in fitting a line, so we have to apply this equation and we have to check it out. So based on the slope that pk values, we decide either we have to go to next position yk plus 1 or we have to stay back in yk. So first parameter, so p naught, so how we'll evaluate it from pk equal to del y xk minus 2 del x yk plus c. So here p naught equal to 2 del y, so x 0 initial point 2 del x and y naught plus c, where c is, so already told it 2 del y plus del x into 2b minus 1. So if we substitute this, so what we'll get at the end finally 2 del y minus del x we'll get for p naught. This is mere just substitutions. So we'll eliminate the negative, the positive, so equal constants we have eliminated. So this is the Bresenham's line algorithms. So this was summarized here. The logic here is Bresenham's line drawing algorithm for slope is less than 1.0. So if it is more than 1, so we have to reverse this process. So y value will keep on increasing, so x we have to decide. So here input the two line endpoints, that is x naught, x end, so y naught, y end, and store the left endpoint, so that is x naught and y naught in the buffer. So set the color for frame buffer. So the frame buffer position x naught, y naught, that is plot the first points. Then so calculate the constant like so del x, the difference between so x end and x naught. So del y, so y end and y naught. So 2 del y minus 2 del x. So this thing, so initially we have to compute it. So we have to so keep it and obtain the starting value for the decision parameter as p naught equal to 2 del y minus del x. So at every stage is each xk along the line. So starting at the iterations k is 0, perform the following test. So pk value we have to check. If the pk is less than 0, the next point to plot is xk plus 1 comma yk. That is pk plus 1 equal to pk plus 2 del y. So next we have to calculate this. So we have to stay back in yk. So suppose pk value is more than 0, positive value, then so we have to move to so yk plus 1 and pk plus 1 is equal to pk plus 2 del y minus 2 del x. So repeat the step 4. So we have to repeat it until we reach the x end and y end points. So this is the algorithm for so Bresenham's line drawing algorithm. So we'll see an example so how it's working. So coming to the example part. So Bresenham's algorithms, how it's working, I already told that. So every time, so initially we have to calculate so p naught value. So based on the p naught value, our slope is less than 1. So formula is given there, devised, the formula is devised. So we have to calculate the pk. X value we have to increase always, we have to stay back in yk. If the pk value is positive, so y value also we have to increment. So every time we have to check the pk value. So based on that, we'll stay back in the same pixel or we will increment so one more pixel. So in y, so x always it's keep on increasing. So if it is reversed, that is slope is equal or more than 1. So y value is fixed, so it's incremental at each iteration by 1. X value we have to identify it. So by using the same logic, so you have to calculate the so pk p naught value for slope is greater than 0. So this is a sample is given here. Calculate the points, that is the intermediate point to fitting a line between the coordinates. So 2010. So 2010 so 0 starts at the left bottom of our top left of our screen. From there it will start. So coordinate is 2010 and end coordinate is so 3018. So we have to fit a line from 20 x y axis 10 up to 3018. So we have to find the intermediate point, then only we have to fit a smooth line. We have to form a smooth line. So calculate the constant first. The constant here is del x, del y. So 2 del y, so 2 del x. So these things are all just calculated. So as per the given points, the del x is x end minus the x naught, that is 30 minus 20, we'll get 10. And del y value is 18 and 10, which is 8. So del x, del y is calculated. And the decision parameter, so pk equal to del y minus del x. So which is 6, we got it. The decision parameter, see we got it as 6, which is the p naught initial value. As the initial value is more than 0, so case 2 is satisfied. That is pk plus 1. That is pk plus 1 equal to pk, so plus 2 del y minus 2 del x, which is equal to 6 plus so 16, so minus 20. 22 minus 20, we will get 2. So that means so we have to increase the y value. X value is always is increasing. So y value, so we have to increase from 10 to 11. If pk is less than 0, we have to stay back in yk itself. Similarly, step 3 is executed until the endpoint is reached or number of iterations equals to 9. So next iterations I'll tell you so how to calculate it. So what value I got it here. So initially it was 20 and 10. So we calculated it. So we got 6. So that's why x, that is which is more than 0. Now so x y value is increased. So next round pk plus 1 value is calculated as per the equation, so which is 2 here. So next round, so 2 is given as input, so which is more than 0, which means so x value we have to increase it, so that is 22. So y value also we have to increase it. Then once again we have to calculate the pk plus the 1 value. That is actually we have to calculate it to pk plus 1 equal to pk plus 2 del y minus 2 del x, which is 2. We got it 2 plus 2 del y minus 2 del x, which is minus 4. So 2 minus 4 will got minus 2. So next iteration, so we'll take minus 2, so which is less than 0. So in this case, so pk is less than 0. The next point we have to plot is x will be incrementing always, but y value we have to stay back the same position, which is 12 here. So 23 and 12. So because of pk value is less than 0, then once again we have to calculate the pk plus 1 here as per the formula. Pk plus 1 equal to pk plus 2 del y. So actually, so minus 2 plus 2 del y, that is 16, I think. So we'll got 14. 16 minus 2, 14, we'll got it. So we'll got a positive value. So next iteration we'll got this 14. So we have to move to the second condition, which is x value we have to increase, y also we have to increase. We have to identify the pk plus 1 value, that is previous value minus 4, that is 10. So this next iteration also we got a positive value, so which is 10 here. So because of this reason, so we have to increase both x, y value. Pk value is positive, we have to increase y. Pk is negative, we have to stay back in the previous y position. The x is always keep on increasing, so that is the logic of resonance algorithm. So now we'll come to this fifth iteration. So 25 and 14 we are having. So now once again we'll calculate the pk plus value, which is 10 minus 4, 6 we got it. In the next iteration, so we are having 6 in our hands, so which is a positive value. So we have to increase x as well as y here, and pk plus 1 equal to previous that value pk value minus 4, which is 2 here. So the 2 is taken for the next iterations. So it's positive. So in that case, both x, y will increase 27 and 16, the pixel position. So once again, we have to calculate the pk plus 1 decision parameter values, which is 2 minus 4. So minus 2 will get it. So minus 2 will get it. So which is negative value. So in that case, x value will increase. In this case, so x value will increase, y value will stay back in 16 itself. So that case, pk plus 1 value we have to find pk plus 2 del y. So which is 16 minus 2, 14, we'll get it as so a positive value. So next iteration we'll go to the second case, which is pk is more than 0. Both x, y pixel value we have to increase. Otherwise, x value will increase, y we have to stay back. So once again, they are calculating pk plus 1, which is previous iteration pk value 14 minus 4. 2 del y minus 2 del x, which is minus 4. So we got 10. So next iteration, so pk value is 10, so which is positive. So we'll increase the x and y value, and we'll calculating the next addition parameter pk value, which is 6. So we are stopping here. So why? Because we started with the 20 and 10. The endpoint they are given as 30 and 18. So until then, the intermediate points we calculated here. So where we have to stop, we have to start in the x0, y0. We have to stop once we reach the xn and yn. So these intermediate points we have to plot in a graph. We'll see that. So how smooth we'll get a straight line. So previously in DDAs we round off the pixel value. So because of that we got a jagged line. We won't get a smooth line. If you so increase the resolutions, you can see the jagged line we'll get. So because of this rounding off problems only. But here, so we are not rounding off the things. So we are deciding we have to stay back in yk or yk plus n. So based on the logic, so equations we framed So D lower, D upper is there. So which is closer? So we'll move forward to next pixel position, or we'll stay back in the same positions. So because of that logic, that jack line is reduced here. Just to see the outcome of this. So this is the output actually. So what we got it here, we started with 2010. So next we got 2111, then we got 2212, then we got 2312 itself, then we got 2413, then 2514, then next iteration 2615, then next iteration 2716, then after that 2816 we stayed back here, then 2917 and 3018. So maybe in two positions only we stayed in the previous YK value. So that is in 2312 and in 2816. So jack lines, that point is reduced here. So because of this logic algorithm so devised by Bresenham. So that is the advantage of this algorithm. So in next sessions we'll see how to draw other shapes, geometrical shapes like circle, so which is included in this lens. Okay, thank you students.